Now, as far as the intercepts of a line, well, what are the intercepts? I guess I should start with that. The intercepts of a line, if we have a line in our graph here, this is the x-axis, right? So where the x-axis, or where the line crosses the x-axis, this is the x-intercept. And where the y-axis and the line intersect, this is the y-intercept. So if you look at this, I said that there's something true about every x-intercept of every line. Well, if you think about an x-intercept, it has to be on the x-axis, right? Which means it's not above or below the x-axis at all. So if you think about what that means as far as one of the two coordinates, well, it actually means that the y-coordinate is 0. If we're talking about the x-intercept of a line, where it crosses the x-axis, that means the y-coordinate has to be 0, because it's not above or below at all. Similarly, if we're talking about the y-intercept, this one up here, well, it might not be up here, it might be down here, it might be somewhere up there, it's never to the left or to the right, which means I'm describing where the x-coordinate is. The x-coordinate is always 0. So this kind of throws some people off. If I'm talking about the y-intercept, I actually know something about the x-coordinate already. So if I wanted to find the x and the y-intercepts of this line, well, that's just saying what happens when my two intercepts, or when my two coordinates are 0 individually. So if my x-coordinate is 0, let's think about which intercept I'm describing here. Actually, I'll just do it down here. If my x-coordinate is 0, if I'm not to the left or to the right at all, that means I'm describing a y-intercept. I'm somewhere on my y-axis. So if my x-intercept is 0, then that means in this equation, well, 2 times 0 plus 3y equals 12. That part just goes away. I get 3y equals 12. Usually when I'm reading these, I actually just cover this up with my finger. I just read 3y equals 12, and well, 3y equals 12, I can solve that by dividing both sides by 3. I get y equals 4. So that, what I said here is that if x equals 0, y equals 4, which means the point 0, 4, well, that's my y-intercept. 1, 2, 3, 4, up here. All right. If I wanted to find my x-intercept, I would just figure out when y is equal to 0. I don't really have to think about which intercept I'm finding. I just need to say if x equals 0, I get this. If y equals 0, I get this, and then plot those points. All right, so if the y-intercept is 0, or sorry, not the y-intercept, if the y-coordinate is 0, then this term ends up going away because I get 3 times 0. So I get 2x plus 3 times 0 equals 12. That part goes away. I get 2x equals 12, or x equals 6. So I said if y equals 0, x equals 6. This is the point 6, 0. 1, 2, 3, 4, 5, 6. The point 6, 0. And hey, look at that. I've actually found 2 points on this line. I have enough information to graph this line. Now, likely, coming into this class, you've probably relied heavily on the slope-intercept form for graphing. The slope-intercept form does work perfectly fine, but for the purposes of this class, this method that I just showed you right now, this actually, graphing by plotting the intercepts is what it's called. This is actually going to work better for a lot of questions that we end up seeing in this class, because we end up dealing with large numbers. You know, we're going to do quite a bit of real-world type problems, and let's say this was 200x plus 300y equals 1200. If I wanted to try to graph this using the slope and the y-intercept, I would end up having a, well, I guess I would still end up finding the point 0, 4, but then okay, maybe this is a bad example. Let's make 2x plus 3y equals 1200. There we go, I like that better. This would be the point 0, 400. And then if I tried to use my slope, I would go down, what would my slope be? It would be down 3, or no, down 2 to the right 3, down 2 to the right 3. Basically, if I'm trying to use my slope, the actual numbers aren't too incredibly important here. The secondary point that I find would be way too close to the first point. And I wouldn't know what's going on over here necessarily. I might be able to guess it looks something like this, but trying to figure out where it crosses over here or how it interacts with anything over there just wouldn't be very reliable. Instead, it would be probably better to find the x and the y-intercept, the point 0, 400, the point 600, 0, and then connect those 2 points. And you already get 2 points that are fairly far apart, so actually it aids quite a bit in the accuracy of drawing this.